Hello students, welcome to Med Academy. So let us begin with the class. So today we'll start, or you can say that I will take a topic which everyone might find it a little bit difficult, right? Let's say today I'm going to start with a topic known as, one second, students. Okay, so today I'm going to talk about redox reactions. So basically what I'm going to take today is I'm going to talk about the balancing of the equation. As we know that in NCERT there are two methods to balance an equation, or you can say a redox reaction. One is the by your oxidation number method and one will be the ionic state method, right? So today we are going to discuss about the ionic one, right? Now before moving to that particular balancing of the equation, the very basic thing which you need about you need to know about a particular reaction is to find out its oxidation state, right? Because if you don't know how whether the particular reaction has gone through a oxidation or reduction, whether you have to do its balancing or not, you need to first calculate the oxidation state of each element, right, involved in the reaction. Okay, so first I'm going to talk, or we are going to learn about how to calculate the oxidation states of any compound which is given to you, right? So let us put the first heading, that is your oxidation state, oxidation state, oxidation state or oxidation number. Okay, now I will not take much time to explain this because my major portion is to talk about or teach you that balancing of the reaction, because that is the part where students find it difficult to understand or to balance out the equation, and majorly those type of questions are only asked in the examination, right? So okay, so let us first talk about what is this oxidation state or oxidation number. So basically it is the formal charge. Okay, it is a formal charge. Now what do you mean by formal charge? Let's say I have a compound. What is this? This is HCl, right? Now if I ask you that which one of this is more electronegative, so you will say that chlorine is the one which is most electronegative than hydrogen. So similarly, the electrons which are there, they will be more pulled towards your chlorine, and hence there will be a minus negative charge which will be on your chlorine and a partial positive charge which will be on your hydrogen, right? Now this charge is nothing but the oxidation state, or you can say the formal charge. So you want, you can write the definition also in a covalent, in a covalent bond, in a covalent bond, assigning 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 a negative charge to the electronegative element, electronegative element. Now one more thing very important, okay, based on their electronegativity, one more thing very important, as you can see I have mentioned a word over here, covalent. Okay, so never forget this, because let's say if I am taking this element, which element I'm talking about, let's say this pph3, pph3. Okay, so if I say that this particular electron is going to donate to this particular metal cation. Now I know these things are a little bit off track, but just try to understand what I'm saying. Is there are two type of bonds which you have learned about so far. One is the ionic and one is the covalent. There is one third category which lies under covalent only, which is called as a coordinate bond. Okay, now coordinate bond is something where there is a donation of a two lone pair of electron or a pair of electron, right? So whenever there is a coordination or coordinate bond taking place, the formal charge which will be there, okay, on the particular metal ion or whatever it is, that will be zero. Zero means, let's say if I am writing this compound, now if I ask you that Now if I ask you that what will be the oxidation state of my metal, so you're going to write it as 0. Why? Because this is a coordination compound. Again, I'm saying why it is a coordination compound, because there is a lone pair which is going under donation. So always remember this, you're going to assign a formal charge only to your covalent bonds. That is, the charges are going to take place only in covalent bond. Okay. Never apply this concept to your coordinate bond. Okay. Because what happens is when they are going to break, okay, let's say I'm breaking this bond, these 2 electrons were wholly coming from your this particular donor, right? So he will take away this both the electron. Okay, there is nothing going to be left over here, right? So that's the reason the amount of electron which he gave, not he it donated, and the amount of electron when it is going to take away during the dissociation will be same, right? So hence what is going to happen over here is there won't be any formal charge. Okay, or you can understand in this way that in covalent bond there is a sharing of the electron. Okay, so wherever there is a sharing of electron, you will always you will be seeing a charges over there. Okay, but if there is no formal sharing, as you can see, I said this is not a sharing, this is not even a complete transfer. What is this? This is basically a donation. Okay, it is basically a donation. Okay, a kind of a donation which is taking place. It is not complete donation, otherwise we will call it as ionic. Okay, it's not ionic, it is just a kind of a donation which is taking place over here. So hence the formal charge will be 0. Just apply it in this way that coordinate bonds does not have any formal charge, do not have any formal charge. All the neutral compounds, let's say H2O. H2O is what? It is a neutral compound. Now we call it as a neutral compound because overall oxidation state will be 0, right? But we know that it's a polar compound. Okay, but overall state formal charge is 0. So let's forget everything. If you have not got this part, it's okay. Today it's just to understand that what you're going to learn, how you're going to assign the oxidation state of a particular element in the particular compound. Okay, let's say if I have taken this example of H2O, if I want to assign the oxidation state of my oxygen, how I'm going to do it? Now again, as I said that this is a kind of a polar compound. Now why it is a polar compound? Because you can see there is what? A negative electronegativity difference between your hydrogen and your oxygen. So hence here it will be a -1 charge, then here it will be a +1 charge, because these both electrons are going in sharing, and both of them will be more helded closely towards the oxygen because of its being electronegative, right? Similarly for this also positive. Okay, so overall what is the oxidation state of the oxygen is -2. Okay students, I hope everyone is getting this point. Again, if I say, let's consider this one. Why I'm teaching you this oxidation state calculation is because when I'm balancing the equation, the very first and the foremost thing you should know is to balance to calculate the oxidation state. Because if you don't know that, you won't be able to come to know that whether which one is the oxidation part and which one is the reduction part. Okay, which is going under which species is going under oxidation and the other one is going under reduction. So for that purpose, you need to first calculate the oxidation state. Okay, so I hope if few of you might be knowing it, you can just increase the playback speed and go to the next part. Now coming back to here, what will be the oxidation state of your sulfur? So many of you have learned it in this way also, that let's consider sulfur, we'll call it as X, we don't know, and there are 2 oxygen, means 2 into -2, right? Because the overall formal charge on per oxygen will be -2, and in that case we have 2 oxygen, so overall it will be -4 is equal to 0, X is equal to +4, right? Or else you can do one more thing, is you can just break them up. Okay, here you will get +1, so -1, then there are one more bond, +1 -1, then again here +1 -1, and then +1 -1. Okay, so overall charge, if you count, it will be +4, right? Okay, so I hope I guess things are getting bit clearer to you. Let's calculate for this. First you should know the structure. If you don't know the structure, it won't help you out. You have been studying this in your chemical bonding, how to calculate the structure. You can just calculate its hybridization. Okay, so just calculate it. I hope everyone knows the structure of H2SO4. If you don't know, you can open your textbook chemical bonding and you can read from there. Yeah. So coming back to here, if I want to calculate the oxidation state of your sulfur, how you're going to do it? Again, you can go by that particular simple method like this, or you can just calculate this calculative method. Use this calculative method, which we use it often. So I will do it in that way only. So if I do it in that way, what I'm going to do, x plus this time how many sulfurs oxygens are bonded. You can see 1 2 3 4, right? So you can do it in this way, plus 2, right? And then plus 1 and then plus 1. So overall there will be oxidation state of plus 6, right? There will be a oxidation state of plus 6. If you want, you can just calculate it in this way also, minus 2 into 3. Okay. One more thing, that if I am asking you to calculate the oxidation state of Cl2, N2, that is your diatomic gas, neutral compounds, which is in elemental most stable form. So in this case, phosphorus, which is P4. So in all these three cases, your oxidation state will be 0. Oxidation state will be 0. Now, why it is 0? If I talk about, as they are stable, that is the reason. Okay, that is true. But what is the other reason? If I draw chlorine, you can see there is no electron negativity difference, right? They both are pulling the electrons with the same force, right? So hence, both of them we are going to get 0, 0. That's the reason the overall oxidation state is going to be 0. So these are the few things you should know before moving or jumping to the balancing of the equations, right? Sure. Now let's move to the major part, which is your what? Balancing of the equation, that is balancing of chemical equation. Now, if I talk about this method, there are two methods. Okay, one is your ion-electron method, which we are going to discuss in this class, ion-electron method. Which one? This one is the most important, because most of the time this is majorly asked, and students find difficulty problem in this solving or balancing it out. So I'm going to discuss this method. Okay, and the other one is your half method, or you can say half oxidation method, reactions of oxidation methods. Okay, so the very first one, that is your ion electron method. You should know few rules. Okay, few rules are required to understand this particular method. If you follow these rules, I'm very much sure that you will be able to balance out the reaction. Okay, so the very first reason, or you can say how to identify that whether the equation is need to be balanced out with this method or the oxidation state method, is the written equation will be in the ionic form. Okay, so that is your write the given equation in ionic form. Okay, it will be given to you. If they have given to you, well and good. Okay, and if they have not, then you are going to write it. Most of the time it will be given to you, because they will just ask you to balance it out, right? Then second one is identify. One more thing, please make sure that you are able to follow each and every point. If you are missing out with any one of it, you won't be able to balance out the reaction correctly. Okay, so please try to read each and every point and able to apply it. We are going to do examples, 2-3 examples. There are 3 examples which I'm going to take. One is in the neutral and acidic medium, and one is in the basic medium. No need to get confused at all. All the 3 are very easy, very simple. Okay, now focus on this. The second one is identify the elements undergoing oxidation and reduction. Definitely you need to first know that which one, to balance out the reaction, you need to first know that which one is going under oxidation and which one is going under reduction. Okay, I hope everyone knows what is oxidation. That is your loss of electron, that is increase in charge, right? Increase in charge or oxidation number is called as your oxidation. And what is reduction? Decrease in charge or decrease in oxidation number. Okay, I hope if you don't know it, I have just mentioned it over here. Write the third point. What is the third point? Break the equation. Now, why I'm making you know these points is because if you don't know these points, you won't be able to do the balancing properly. Okay, into two halves. Into two halves. One is your oxidation half. Oxidation half. And the second one is your reduction half. Reduction half. Okay. What is the next point is? Fourth point is balance out. We are going to take the example, students, so don't worry about it. Just now, keep yourself calm and listen to each and every point which I'm writing on the screen. So balance the half equations. Okay. Now, what is the fifth point? Fifth point is your balance all the atoms. Balance all the atoms. All the atoms except oxygen and hydrogen. Okay, and then finally you have to balance oxygen first. Okay, and then balance your what? Hydrogen. Please follow the sequence. First you are going to balance oxygen and then balance hydrogen. Okay, so balance all the atoms except oxygen and hydrogen, then balance oxygen by adding what? By adding this. All are given here in NCERT. You can read from there. None of the points I have given by my own. Everything is from your NCERT. Okay, by adding H plus ions. And how you're going to balance out the hydrogen? By one second. Balance oxygen by adding H2O, not H plus. That you're going to do with your balancing of your hydrogen. So by adding H2O, and then balance H, that is your hydrogen, by adding H plus ions. By adding H plus ions. And then last one is your balance the charge. Okay, I'm writing over here. The next one is your balancing the charge. Obviously, if you want, if you have whenever you have seen an equation, you have to balance the charge, balance the atom, and balance the mass. Everything should be balanced, right? So balance the charge by adding what? What you're going to do if you want to balance the charge? Let's say if there is 5 positive charge on one side, and then you have to balance it and there is no charge on the other side. So what you're going to do? You're going to just simply add the number of electrons. Let's say 5 H plus is there, so you're going to add 5 electrons, so that overall on both the sides it becomes neutral, right? So here it will be balancing the charge by adding number of electron. Okay, by adding electrons simply. And the last one is your fifth one is add the two halves. Add the two halves such that electron in two halves gets cancelled. Okay, I hope each and every point is cleared. If it is not clear, no problem. Let us take an example. Okay, so if you guys are writing, you can just pause it. You can read once again. Okay. Okay, now let us begin by doing a few examples. I'm clearing this up. Okay, so the first example is, let's say, examples. Put the heading as examples. Fe plus 2 plus Cr2O7. This is what dichromate ion gives. Cr plus C plus 3 plus your Fe plus. Now, as you can see, in both the sides, ions are involved. So obviously, the equation is going to be balanced out with your ionic method. Okay, so the very first point was go back and see, write the equation in the ionic form, which is already there. Second is identify the oxidation and reduction. Okay. So which one is doing the oxidation? As you can see, there is an increase of the oxidation number. So this is the oxidation part, right? And there is a decrease in the oxidation. Now, how I'm going to calculate the oxidation state of this? How I'm going to do it? 2x plus your 7 minus 2 is equal to minus 2, right? So this will be equal to 2x minus 14 is equal to minus 2, x is equal to plus 6, right? So your chromium is in plus 6 oxidation state, and then it is getting decreased to plus 3. So hence this is a reduction. Okay, that now you got it why I taught you first the oxidation states of the elements to calculate it, because before that you can't be able to balance out the equation. You need to know that first. Okay, then what is next is break the equation into two halves. Okay, let us break it into two halves. We know which one is going under oxidation and which one is going under reduction. Just write them out. Oxidation half, which is your Fe plus 2 to your Fe plus 3. Okay, done. Next one is your reduction half. Do that. Reduction half. Okay, so reduction half is your chromium plus 6 to your chromium. Okay, let's not write this. We'll write the whole compound given as it is, because we have to balance out everything. Cr2O7 minus 2 and your chromium plus 3. Okay, now read the next point. You have done this. Now balance the half equations. Okay, we are going to do that. How you're going to balance it? First point is balance all the other atoms except oxygen and hydrogen. Okay, so as you can see over here, we have to balance the equation by except oxygen and hydrogen. So as you can see here, it is only one atom, and here it is only one atom. So no need to balance it. Now here you can see there is two chromium ions which are present. So here only one. So you're going to multiply it with 2. Okay. Now next is what? Next is balance the oxygen. First you have to balance out the oxygen by adding H2O. Okay, H2O to the other side deficient in oxygen. Okay, so I guess I have not made you write that whole entire point. So you have to balance the oxygen in such a way that add those many number of water molecules to the other side which is deficient. Other side which is deficient means, as you can see, there are 7 oxygen which is present over here, right? 7 oxygen atoms are present. So I have to add the water molecule to the other side where there is a deficient of what? Oxygen atoms. So how many water molecules I should add? Those many water molecules which is comparable with your oxygen atoms. So 7H2O I'm going to add. Okay. Now what I'm going to do is next is I don't need to balance over here because there is no oxygen and hydrogen present over here. I will just balance out this. Okay, now next is I have to balance out hydrogen. How you're going to balance out the hydrogen? You can see there are total 14 hydrogen which are present over there. So you can read the point. Balancing out the hydrogen needs to be added by adding H plus ions, those many number of H plus ions. So you can see there are 14 hydrogens. So here we will add 40 H plus. Okay. Now next point is what? Balance the charge. Okay. Now how you're going to do the balancing of the charge? By adding those many number of electrons, right? Those many number of electrons. So just balance out how many charges there? 14 H plus minus 2, 12, right? And here it is plus 3 and 2, that is plus 6. So here there is total charge of plus 6 and here it is total charge of plus 12, right? So if I want to make them neutralize, or you can say balance out, so what I can do is I can add over here minus plus 6 electrons. So what I am going to get? Plus 6 over here and plus 6 over here. Okay, right? Now last one is your add the two halves in such a way that the electrons in both the halves get cancelled. So do I need to balance over here charges? As you can see, atoms and everything is charged, everything is balanced out, but the electrons are not balanced out, right? So for that, how many electrons I need to balance out here? You can see there is +2, here it is +3, so I need to add one more electron so that the charge get balanced. Right now, if I want to combine both of them, I need to cancel out the electrons. How many electrons are present over here? 6. So I need to balance it, multiply it with 6. Okay, so if I multiply it with 6, what I'm going to get? Fe plus 2 to Fe plus 3 plus 6 electrons. Now the reaction has almost got balanced. Just cancel it out and then just add it. So if you add it, what you get? 6 Fe. You're going to multiply it with 6. So 6 Fe plus 2. Okay, plus your 14 electrons, 14 H plus your chromate ions minus 2 will give me 6 Fe plus 3 and plus 6 electrons plus 2 chromate plus 3 ions plus your 7H2. Okay, so if you want, you can balance out once again. There is one Fe atom, then there is total charge of how much? 6 2s are 12, 14. Okay, 6 2s are 12 plus 14. 12 plus 14 is how much? 26, 24. Okay, and here also 6 3s are 18, 18, and 2 3s are 6. 18 plus 6 is how much? 25. Okay, so one charge, so 20. 1 second. 6 3s are 18 and 2 3s are 6. 24, right? So here it is 24. Oh, 1 second. This was cancelled out. Why I'm writing this? This is not there. So here it is total charge is 24. Here also it is total charge is 24. You can see hydrogen are 7 2s are 14. Here also 14. Chromate is 2, 3 plus. There is also 2 chromate ions. Okay, so overall the charge is balanced out. So this is the method. This is how you're going to balance it out. Okay, now remember one thing, the rules which I given you, that is applicable for your neutral and acidic part. Okay, both the type. If they ask you to find out, do the balancing in the neutral medium, same rules you're going to apply. And if they're asking you to do it in acidic medium, same rule you're going to apply. Okay, what we did, once again I'll recap. The equation was in ionic state. So by itself, you will come to know that it will be in a ionic form, right? Then see which one is going under oxidation and reduction. Write them in 2 halves. Okay, now first balance out the number of atoms except your oxygen and hydrogen. Then next, once you have balanced it out, then now balance the oxygen first by adding that many number of H2O molecules, okay, on the side which is deficient. Then after that, add H plus ions, okay, according to your number of hydrogen atom. Then balance out the charge by adding the number of electrons, and then cancel out the number of electron by multiplying them. Okay, and then finally add them up. Okay, so this is the way you're going to do in neutral and